Hey guys, here we're going through AQA's June 2018 Higher GCSE Maths Paper 3. Now I usually think Paper 3 is the nice one out of the three of them, so let's see how we go. I'll put links to the other two papers down below in the description, as well as some other useful links to topic playlists to help with questions in this paper. You'll need to know formulas for GCSE Maths and a few other bits and bobs. Let's do this. Okay, question 1 wants us to circle the decimal closest to 11/20. So the first thing we're going to do is use our calculator to turn this into a decimal, which is 0.55. So what we can do then is find the difference between these numbers and 0.55. So 0.56 minus 0.55 is 0.01. 0.6 minus 0.55 is 0.05. So that's further away. If we do 0.55 minus 0.525, we get 0.025, so that's further away than our first number. And if we did 0.55 minus 0.5, we get 0.05. So the closest number is 0.56. Question 2 wants us to circle the list of integers satisfying the inequality x is strictly bigger than -2 and less than or equal to 4. So x is not allowed to equal -2 straight away. Those two can go bye-bye. Now x is allowed to equal +4. So we don't want this top guy, we want this bottom right guy. Question 3 wants us to circle the largest number. So our first number is 3.27 recurring. Now that means the 7s go on forever. So 3.27 is going to be smaller than that. 3.277 is going to be smaller. And 3.207 recurring is going to be smaller because that has a 0 where this first number has a 7. So 3.27 recurring is our guy. Question 4 asks us, what is the size of the exterior angle of a regular decagon? So, the sum of exterior angles is always 360. No matter how many sides your shape has, the exterior angles always add up to 360. Now, it's a regular decagon, so the angles are going to be the same size. We have the same number of exterior angles as we do sides of the shape. A decagon has 10 sides, so the exterior angle is 360 divided by 10, which is 36 degrees. So there's our guy. Cool. Question 5 says A is a common factor of 72 and 120. B is a common multiple of 6 and 9. We want to work out the greatest possible value of A over B. So, for this fraction to be as big as possible, we want the biggest value of A divided by the smallest value of B. So what we're looking for here is the highest common factor of 72 and 120, and then the lowest common multiple of 6 and 9. So we could do this using product prime factors. It's probably quicker though, just to list. So let's list all the factors of 72. So we got 1 and 72. We got 2, 24. That's rubbish. We got 2 and 36. Then we got 3 and 24. 4 and 18. 6 and 12. And 8 and 9. So there are all the factors of 72. We're going to do the same with 120. So we get 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, and then 10 and 12. So we are looking for the highest common factor, so the number that turns up in both of these, or the biggest number that turns up in both of these, and that is 24. So the value for A that we're going to use is 24. Okay, then for B is a common multiple of 6 and 9. Now we want the lowest common multiple of 6 and 9 because we want the smallest number for B. So what's the first number that 6 and 9 both go into? It's 18. So B is 18. So our value for A over B is going to be 24 over 18, which simplifies to 4/3. So 4/3 is our answer. Cool. 6. A and B are similar shapes. B is an enlargement of A with a scale factor of 1.5. So when shapes are similar, the angles inside stay the same, but the lengths are multiplied by a scale factor. So, to get from A to B, we multiply the lengths by 1.5. To get back from B to A, we divide the lengths by 1.5. So the question asks us to work out the value of X, H and W. So X, first of all, is this angle up here. Now the angles stay the same, so X is still going to be 54 degrees. Okay, now H is this guy here. On shape A, that length is 5, so h is going to be 5 times the scale factor, so 1.5, and that's going to give us 7.5 centimetres, and then W is this length here. Now the corresponding length on shape B is 9. So W is 9 divided by the scale factor. So 9 divided by 1.5 is 6 centimetres. Good times. In 7 we got some percentage increase, so I'll put my percentage increase and decrease playlist down below. So we got these two investments. Investment A, we're going to save £150 per month for 2 years, and then 2.5% interest is added to the total amount. And investment B, we're going to invest £3,500 and we get compound interest paid at 3% per year for 2 years. We want to work out how much more is investment B worth than investment A after 2 years. So we need to work out how much they are both worth. So let's do A first. So the total amount saved is £150 every month for 2 years. So in 1 year there is 12 months. In 2 years, there are 24 months. So, first thing we're going to do is 24 times £150. And that's going to give us 3,600. Now, on top of that, we now get paid 2.5% interest. So I'm going to use decimal multipliers here. 2.5% is 0.025. So we're going to do £3,600 times 1.025, which increases it by 2.5%, and we are going to get £3,690. Okay, let's do investment B. So for investment B, we're sticking in £3,500 for 2 years, and we get paid compound interest at 3% per year. So for investment B, again I'm going to use decimal multipliers. So 3% is 0.03. So to work out what B is worth after 2 years, we're going to do 3,500 times 1.03 squared, and that's going to give us £3,713.15p. So now we have our two amounts from the investments. We want to know how much more investment B is worth than investment A. So we're now going to do 3,713.15 minus 3,690, and that is going to give us £23 15p. So that is our final answer. Cool. 8a, it says, show that the lines y equals 3x at 7 and 2y minus 6x is equal to 8 are parallel. So I'll put my equations of straight lines playlist down below. If two lines are parallel, it means they have the same gradient. Now, in the general equation of a straight line, y equals mx plus c, m is the gradient. So, in the first line, y equals 3x at 7, the gradient is 3. Now with the second line, we can't read the gradient how it is. We always need a line to be in the form y equals mx plus c. So this second guy, we need to rearrange to get y on its own. So 2y minus 6x is equal to 8. Well, if we add 6x to both sides, we get 2y is 6x, add 8. And then if we divide both sides by 2, we get 1y is 3x, add 4. So, this line also has a gradient of 3. So then I guess we should say they have the same gradient. So are parallel. Cool. Okay, then part B. We are asked, is the point minus 5 minus 6 above, below, or on the line y equals 3x add 7? So, we're not allowed to use a graphical method. So, what we're going to do, we're going to find the value, or find the y coordinate of y equals 3x plus 7 when x is minus 5. So, when x is minus 5, y is 3 times minus 5 add 7. Now 3 times minus 5 is minus 15, add 7 is minus 8. So we get y is minus 8. So on the line, on y equals 3x add 7, when x is minus 5, so at this point where x is minus 5, y is minus 8. So that is a point on the line. So we definitely know that minus 5 minus 6 does not lie on the line. Now, what we're looking at is the y coordinates now of this point. So the y coordinate here is minus 6. Now, on the line, when x is minus 5, the y coordinate is minus 8. So, minus 6 is above minus 8. So the point minus 5 minus 6 is above the line 9 is reverse percentages, so I'll put my video on that down below. So the cost of a ticket increases by 10% to £19.25p. We want to work out the original cost of the ticket. So, the cost of the ticket has gone from 100% and is increased by 10%. So we've added 10% and that gives us £19.25p. So 110% of the original cost of the ticket is £19.25. Now what we want to do, we want to get from 110% back to 100%. So the way to do this is to think of a percentage that goes nicely into 110, that is also going to go nicely into 100. So that would be 10%. So to get from 110% to 10%, we're going to divide both sides by 11. So we're going to get 10% by dividing by 11 is equal to 19.25 divided by 11, which is going to give us £1.75. Now 100% we can get by now multiplying both sides by 10. So 100% is £17.50p. Cool. Okay, question 10 says the nth term of a sequence is 12n minus 5. We want to work out the numbers in the sequence that have 2 digits and are not prime. So I'm just going to work out what the first term of the sequence is. So the first term is when n is equal to 1, so that's 12 minus 5, which is 7. Now that is not a 2-digit number, so we're not interested in that. Now what happens here is the sequence goes up in 12s because we got 12n. So the next term is going to be 19. Then we're going to have 19 add 12, which is 31. Then we're going to have 43. Then we're going to have 55. 67. 79. And 91. So those guys are all of the 2-digit numbers in the sequence. So we want the numbers that are not prime. So 19 is definitely prime, 31 is prime, 43 is prime, 55 is not prime. 5 goes into that. 67 is prime. 79 is prime. 91 is not prime. So the two numbers that we want are 55 and 91. You might be thinking here, well, hang on, how do you know 91 isn't a prime number? So our calculators can write a number as the product of its prime factors. So, for example, if we did it with 55, our calculator would tell us it's 5 times 11. So that means 55 has more than 2 factors, so it's not prime. Same with 91. Our calculators would give us 7 times 13. So also 91 is not prime. If we did it with any of the prime numbers, so let's say we did it with 79, our calculators would tell us, well, 79 as a product of its primes is 79. So 79 is a prime factor. So it's a really cool trick to know how to do. I've got a video called Secret Calculator Tricks, in which this trick stars. So I'm going to link that down below in the description. Check it out. It's really worth knowing how to do it. Okay, question 11. So we got some column vector fun. I'll put my video down below. So we got these 3 vectors, A, B and C. And part A wants us to work out A plus B plus C. So, when we are adding column vectors, we simply add the corresponding parts of the vectors. So, for the top, we need 6, add -1, add -4, and for the bottom we're going to get -10, add 2, add 7. So, up on top, 6 add -1 is 5, add -4 is going to give us 1, and then on the bottom, -10 add 2 is -8, add 7 is -1. So we get 1, -1. Part B wants us to show that A plus 2C is parallel to B. So if vectors are parallel, then they are multiples of each other. So I'll show you what I mean by that as we do the question. So A plus 2C is going to be 6 minus 10 add 2 lots of whatever C is. So C is -4, 7. So to multiply a vector, you just multiply both parts of it. So this is 6 minus 10 and -8, 14. Now that is going to give us 6 minus 8 is -2, and -10 add 14 is 4. So we got -2, 4. So A plus 2C is -2, 4. Now, if we check this out, we've got a common factor here between the top and bottom of 2. So we could write this as 2 lots of -1, 2. Now, if we look at vector B, oh look, vector B is -1, 2. So, we could say this is 2 lots of vector B. So, A plus 2C is a multiple of B. So, A plus 2C and B are parallel. Cool. In question 12, we're told pressure is force divided by area. We're told a force of 14 newtons is applied to an area of 3.2 square meters. We want to work out the pressure, giving the units of our answer. So the pressure is going to be the 14 newtons divided by 3.2 meters squared. 40 divided by 3.2 is 12.5. And the units of our answer is newtons per meter squared. So that's our answer. And 13 is a stupid little 1 mark question that nobody really cares about. So we want to tick all the statements that are true for any rhombus. So I've borrowed this picture of a rhombus here. A rhombus is a squat square. Things are getting pretty heavy, so let's have an awesome maths joke. Why was the mathematician late to the party? Because he took the rhombus. Yeah, terrible, I know. Okay, so first statement then is the diagonals are lines of symmetry. So the diagonals on this lovely rhombus are drawn. Can see we could fold this shape exactly through the lines of symmetry and we would get perfect overlap. So yes, the diagonals are lines of symmetry. The diagonals bisect each other, so that means they cut each other exactly in half. That is true, they do. The diagonals are perpendicular, so they meet at right angles. Also true. So the one that isn't true is that the diagonals are the same length. So hopefully we can quite clearly see the one going from bottom left to top right is going to be longer than the other one. So that one is not true, and that really is such an abstract question. There's no reason why you should know those facts about a rhombus, but there we go. Question 14, we want to draw the graph of 0.8 to the power of x. So the first thing we need to do is fill in the coordinate table as I've done here. So from 0 to 2, it's alright. After that it gets a little bit silly. We start getting decimals with 3 or more places. So it gets sensible to start rounding. So my values, you can see here, so I've rounded to the nearest to 2 decimal places, I think. So then we want to plot the graph. So plot the points, and then as with any graph, join them up. Not with a ruler and straight lines, it's a curve. So try and do the best you can to make it a curve. Hopefully you get something that looks like this. 15. Amy has X beads. Billy has 3 more beads than Amy. Carly has 4 times as many beads as Billy. We want to circle the expression for the number of beads that Carly has. So, starting from the top, Amy has X beads. Billy has 3 more. So in terms of X, that's X plus 3. Carly has 4 times as many beads as Billy. So that's 4 lots of x plus 3. So it's 4 lots of x plus 3. So it's this chap right here. Question 16. 2 straight lines intersect at point A. We want to circle the coordinates of point A. So, what do we know? We know the equation of the slanty line is y is equal to minus 4x. We know the equation of the horizontal line is y equals 3. So, anywhere on this horizontal line, the y value is 3. So we know at this point y is equal to 3. Now that's true for the horizontal line and the sloping line at this point. So remember, we know the equation of the slanty line is y is equal to minus 4x. So at this point, 3 is equal to minus 4x. So if we divide by minus 4, we get 3 over minus 4 is equal to x, or minus 3/4 is equal to x. So the coordinates of point A are minus 3/4 minus 3, which is this first guy here. Cool. In 17, so we got 2 methods to make a 4-digit code. Digits can be repeated in the codes. So method A says for the first 2 digits, use an odd number between 30 and 100. For the second 2 digits, use a multiple of 11. Method B says use 4 digits in the order even, odd, even, odd. We're not allowed to use the digit 0. So we want to work out which method gives the greater number of possible codes. So for method A, so we want 4 digits. So for the first 2, we want an odd number between 30 and 100. So 100 minus 30 is 70. So there are 70 numbers between 30 and 100. Half of them are odd. So a half of 70 is 35. So there's 35 odd 2-digit numbers between 30 and 100. So there are 35 different different 2-digit numbers that we can put in this first 2 slots. Now for the second 2, we want multiples of 11. So they have to be 2 digits. So we got 11, 22, 33, 44, 55, 66, 77, 88, 99. So there are 9 multiples of 11 for the second 2 digits. So, to work out the total number of combinations, well, there are 35 2-digit numbers for the first 2 slots, and 9 2-digit numbers for the second 2 slots. So we multiply those 2 numbers together. So 35 times 9 is 315. So then for method B, we're using digits in the order even, odd, even, odd. We're not allowed to use 0. So, for method B then, okay, so if we're not allowed to use 0, the even digits are 2, 4, 6, and 8. So, there are 4 possible things the first digit can be. For odd digits, we got 1, 3, 5, 7, and 9. So there are 5 possibilities for the odd digits. Digits can be repeated, so it's the same again. So to get the total number of combinations here, we multiply 4 times 5 times 4 times 5, which gives us 400. So method B gives us more combinations with 400. Cool. Question 18, so we got some algebraic fraction fun. I'll put my playlist down below. So we want to show that for x not equal to 0, x plus 4 over 3x minus 5 over 2x can be written in the form ax plus b over cx, where a, b and c are integers. So, probably the easiest way to go with this is common denominators. So on the bottom we got 3x and 2x. So we'd be thinking, what's the first number that 3x and 2x both go into, which would be 6x. So we're going to turn each of the denominators into 6x. So for the first fraction, we're going to multiply the top and bottom by 2. So we're going to get 2 lots of x plus 4 over 6x minus 3 times 5, which is 15 over 6x. Now, we have common denominators, so we can write this as a single fraction. So it's 2 lots of x plus 4 minus 15 all over 6x. Now if we expand the brackets, we got 2x plus 8 minus 15 all over 6x. And if we simplify that, we got 2x. Now 8 minus 15 is minus 7. So we got 2x minus 7 all over 6x. Cool. Question 19 says the equation of a straight line is 3x add 2y is equal to 24. We want to circle the point where the line crosses the x-axis. So on the x-axis, y is equal to 0. So the y term will disappear. So we'll get 3x is equal to 24. Divide by 3, x then is equal to 8. So the coordinates are going to be 8, 0, which is there at the end. Cool. 20. So this one has been a favourite with my minions, and I think everyone out there in general. So we got this right angle triangle. All lengths are in centimetres. However, the lengths are x, 7x, and 10y. We want to use Pythagoras to work out the value of x over y. So this might seem a bit mental at first. However, the question does sort of tell us what to do. So we're going to be using Pythagoras. Now if we call this side A, this side B, and this side C, Pythagoras tells us a squared plus b squared is equal to c squared. So a squared is going to be x squared, b squared is 7x all squared, and then c squared is 10y all squared. Okay, so we've got x squared and 7x all squared. Now that squares the 7 and squares the x. So we've got x squared and 49x squared is equal to 10y all squared. So that's going to be 100 y squared. Now if we simplify the left, we got 50x squared is equal to 100 y squared. Okay, now both sides have a common factor of 50. So I'm going to divide both sides by 50. So we're going to get x squared is equal to 2 y squared. Now let's have a look at what we want. Again, we want x over y. So the next thing we're going to do is divide by y squared. So we get x squared over y squared is equal to 2. And then the last thing we want to do is turn x squared over y squared into x over y. So we're square rooting both sides. So we're going to get x over y is equal to root 2. So our final answer is root 2. Tricky. Question 21, we got some direct proportions, so I'll put my proportion playlist down below in the description. So the mass of an ornament is m grams, the height of the ornament is h centimeters. M is directly proportional to the cube of h. M is 1600 when h is 8. We want to work out an equation linking m and h. So, first of all, the proportion is direct. M is directly proportional to h cubed. So really the first thing we should write is m is proportional to h cubed. So that's the proportion. Now the equation or formula that we use is m is equal to k times h cubed. So our mission here is to find the value of k. Now we do that by substituting in the values that we know. So m is 1600 when h is 8. So we get 1600 is k times h. K times h cubed, which is k times 8 cubed. Now 8 cubed is 512. So on the right there we got k times 512. To move the 512 we need to divide it away. So we get 1600 divided by 512 is equal to k. Stick that in your calculators and we get k is equal to 3.125. So the formula linking m and h is m is equal to 3.125 h cubed. Cool. Okay, then part B wants us to work out the mass when the height is 12 centimeters. So for this we're going to get the mass is equal to 3.125 times 12 cubed. Stick that in your calculators and we will get the mass is 5,400. Cool. We got a tiny little circle theorem question. So we got A, B and C are points on a circle. DCB is a straight line. PAQ is a tangent to the circle. And we got this angle down here, which is 56 degrees. We've also got this missing angle up here, angle M. So, Sam is trying to work out the size of angle M. We've got his workings here. And our mission is to make a criticism of his work. So he's saying the angle ACB is 56 degrees. And then he's saying angles in the same segment are equal. Now we can stop right there. That is his mistake. Angles in the same segment are things like this. So the angles in the same segment theorem would tell us that this angle is equal to this angle. Now we can clearly see we don't have that situation going on in this circle. The theorem that we would use is that this 56 degree angle down here is equal to this angle here. So he's right saying that, but he's used the wrong theorem. This theorem is called the alternate segment theorem. So just to point something else out, by the alternate segment theorem, this angle here would be the same as that angle in there. So he's actually got the right answer, but he's used the wrong theorem. So he's used the wrong theorem. It's alternate segment. Cool. So I'll put my circle theorem stuff down below. 23, we got some iteration, so my stuff is down below. The sequence of numbers is formed by the iterative process. Un plus 1 is 3 over un plus 1. And u1 is equal to 4. We want to find u2 and u3. So, u2 is 3 over u1 plus 1, which is 3 over 4 plus 1, which is 3 over 5. Now we're going to turn that into a decimal, so that's 0.6, and then U3 is 3 over U2 plus 1, which is 3 over 0.6 plus 1, so that's 1.6, and that gives us 1.875. Cool. 4. So the speed time graph shows 20 seconds of a car journey. How he wants to estimate the distance travelled in this time. He uses a triangle and a trapezium as shown to estimate the area under the graph. So there are his triangle and trapezium. We want to complete Harry's method to estimate the distance the car travelled. So the reason we're doing this is distance under a speed time graph, area under a speed time graph gives us the distance. So we need to work out the area of this triangle. So let's do that first. Now the base length is 10. The height is 20. So the area of a triangle is 1/2 base times height. So the triangle is 1/2 times 10 times 20, which is going to give us 100 meters. Okay, then for the trapezium, we need the second height on the right, which is 30. And then we need this horizontal length here, which is also 10. So for the trapezium, first of all we need to remember the formula for the area. So we call the height H, the top A, and the base B. The area is the height times A plus B, all divided by 2. So we need to draw this trapezium a little bit different. It needs to sit down. So the base is going to be 30, the top length is going to be 20, and the height is 10. So the area is 10 lots of 30 plus 20, so 50. So 10 times 50 all over 2. 10 times 50 is 500, divided by 2 is 250. So the estimate for the total distance travelled is 100 at 250, which is 350. Cool. Okay, then part B says, for the journey, which of these statements is true for Harry's method? So, does it work out as an overestimate, an underestimate, or we cannot tell? So, let's go back to the graph. The triangle fits exactly in the graph, so that's no problem. The trapezium, however, doesn't take into account all of this area here. So we only have the area of the trapezium. We don't have that green area. So we've actually worked out a smaller area under the curve than is actually the case. So we've worked out an underestimate. Question 25. So A, B, C, D, E, F is a triangular prism which represents part of a hill. A, B, C, F is the horizontal rectangular base. D is exactly above C. We want to work out the height CD. So we need to work out this height here. So notice here this bottom angle is a right angle. We got this other angle over here of 6, and we know this base length of 500. Now this shape on the side is a right angle triangle. So we can say the base is 500. This angle over here is 6 degrees. So we can use trigonometry. Trig. So with regards to that angle, the x length is the opposite. 500 is the adjacent. So, no, no, Torah, yes. So, Torah tells us tan of 6 is the opposite, so x over the adjacent. So, to get x on its own, we multiply through by 500. So we get 500 tan 6 is equal to x, which gives us, if we go to one decimal place, 52.6 meters. Cool. Okay, then part B is probably a little bit trickier. So we're told Jamil walks from point A to point D. So he's walking up and diagonally across the hill. So here I've shown this with the red line. Now, the question asks us to work out the angle DAC. So that is the angle that we would get if we could go from point D to A to C. So here I've shown this with this purple angle X. So I've also put on the line AC, which here is the blue line. Now it's important to realise that is the diagonal of the horizontal base. So we're dealing again with a right angle triangle here, and I've also put on the length that we worked out in part A. So we want to work out this angle X here. We're in a right angle triangle, we know one side length. What would be really cool is if we could work out either the red length or the blue length. Now we can actually work out the blue length because it's the horizontal of the base and we know the two side lengths of the base. So if we make a sketch, then this length is 400 and this length is 500. Now the blue line is this diagonal. So we're going to use Pythagoras. So if we call the 400 length A, 500 length B, and the blue line C, Pythagoras tells us A squared plus B squared is C squared. So 400 squared add 500 squared is c squared. 400 squared add 500 squared is 410,000. So that is c squared. If we square root, then we get c is equal to, now I've gone to one decimal place here, 640.3. So that is meters. Okay, so what we now know, in our right angle triangle, is we know two lengths. So to work out angle x now, we can use SOHCAHTOA again. So the 52.6 is the opposite, 640.3 is the adjacent. So we're using tan again. So this time, tan of x is 52.6 over 640.3. So x is the inverse tan of that fraction, which gives us x is equal to 4.7 degrees to one decimal place. So 4.7 is our answer. Okay, question 26. So the histogram shows information about the speeds of cars as they pass a checkpoint. The scale on the frequency density axis is missing. So that's a shame. The histogram shows information about 480 cars. We want to work out how many cars the first bar represents. So what we need to do here is find the scale for the frequency density, and then that will allow us to find out how many cars are in that first bar. Now, I'm going to put a link to my histogram stuff down below. A quick little recap though. The area of a bar, so where are we going to write this? Let's write this up here. The area of a bar is the frequency represented by that bar. So, if we look at the bars, they are rectangles. Along the bottom, we have the interval width. Going up the side, we have frequency density. So, we can say that frequency density times interval width is equal to the frequency. So we're going to be using that formula. So with that formula in mind then, the first thing that we can say is that the total area is going to add up to 480. So now we need to be a little bit clever with our scale and the side. So we don't know anything about the scale. Now, looking at the bars, the first one goes up to like a nice whole big square, but the other two don't. So what we're going to do, we're going to pick a scale for our frequency density. We're going to say every little square is worth x. So, with that in mind, we can now work out the areas of each bar in terms of x. So this first bar is 1, 2, 3, 4, 5 big squares high. Now that's each big square is 5 little squares. So the height here is 25x and the width along the bottom is 15. So for the first bar, we get an area of 15 times 25x. So 15 times 25 is 375x. Okay, for the second bar, well, this time we're going 6 big squares, which is 30x, and then another 3 little squares. So the height of this guy is 33x, and the interval width is 5. So for the second bar, the area is, the area is 5 times 33, which is 165x, because it's 5 times 33x. And then for the third bar, well, the height here is 4 little squares, so 4x, and the width is 15. So the third bar has an area of 15 times 4x, which is 60x. Okay, so what we can now do is work out the total area in terms of x. So the total, so if we add all of those together, we get 600x. So that is the total area in terms of x. Remember that we know the total area as a number. It's 480. So we can now use this to find our value of x. We're going to set the total in terms of x equal to the numeric total. 600x is equal to 480. If we divide by 600, we get x is 0.8. Okay, so now we know what x is, we can work out how many cars the first bar represents. So remember, we said the first bar in terms of x had a frequency 375 times x. Now we know what x is, we can do 375 times 0.8, and that gives us 300. So 300 is our answer. Cool. Okay, then part B says cars that are over the speed 40 miles per hour are over the speed limit. We want to use the histogram to estimate the number of cars over the speed limit. So, back to the histogram. Find 40. There it is. So anything to the right of that, we're going to use as our estimate for cars over the speed limit. So we need to find the area of this bar. So from 40 to 50 is a length of 10. Now we know, remember, x is 0.8. So the height of our rectangle is 3.2. 4 times 0.8. So we're going to do 10 times 3.2, which gives us 32. Good times. 27. So a bag contains 30 discs. 10 are red and 20 are blue. One disc is taken out at random and replaced by 2 of the other colour. Another disc is then taken and replaced by 2 of the other colour. A third disc is then taken. We want to work out the probability that all 3 of the discs are red. So, we need to be really careful and just think a bit logically about this. So, on the first selection, 10 are red, 20 are blue. So, for the first selection, the probability of red is 10 out of 30, which simplifies to 1/3. Now, if the first selection was red, then, well, if we took out 1 red, that stays out, and we put in 2 more blue. So there's now going to be 9 red, and there's going to be 2 more blue. So there's going to be 22 blue. So now the probability of getting a red on our second selection is 9 out of 9 add 22. So 9 out of 31. Now, if our second selection was red, well, again, there's going to be 1 less red, so there's now going to be 8 red, but there's going to be another 2 blue, so there's now going to be 24 blue. So on the third selection, the probability of getting a red is 8 out of 8 add 24. So 8 out of 32. So we now know the separate probabilities at each stage. If we picked a red on the first try and then a red on the second try, we want the probability of getting a red, then a red, then a red. So to do that, we multiply each of the separate probabilities together. So we got 1/3 times 9 out of 31 times 1/4. And that is going to give us 9 over 372, which simplifies down to 3 over 124. Cool. Question 28, the grand finale. So we got equations of tangents. Now these are really worth being able to do. Look at this guy, it's worth 5 marks. So I'm putting my playlist for equations of tangents down below, which has all the separate skills that we need. So point P lies on the circle with equation x squared plus y squared is equal to 80. Point P has x coordinate 4 and lies below the x-axis. So we know the x coordinate is 4, we don't know the y coordinate just yet. So we want to work out the equation of the tangent to the circle at point P. So the first thing we're going to need is the y coordinate of point P. When we got that, we can work out the gradient of the radius. When we got that, we can work out the gradient of the tangent. And then when we got that, we can work out the full equation. So we know point P has coordinate or x coordinate of 4. So what we're going to do to find the y coordinate is substitute x equals 4 into the equation of the circle. So we get 4 squared, which is 16, and y squared is equal to 80. Take away the 16, y squared is 64. Square root, and we get y is plus or minus 8. So remember, we are told we are below the x-axis. So the value that we want is minus 8. So we now know both the coordinates at this point P. Now we know the centre of the circle is the origin. So this point is 0, 0. So what we can now do is work out the gradient of the radius. The reason that we're going to do that is because a radius and a tangent are perpendicular, and the gradients of perpendicular lines multiplied together to minus 1. So it's going to allow us to work out the gradient of the tangent. So the radius is a line coming out from the centre to point P. So I'm going to call this M R, so gradient of the radius. Now gradient is the difference in y divided by the difference in x. So here I'm going to do minus 8 minus 0. Now because I've done minus 8 minus 0, I then have to do on the bottom 4 minus 0. Now this gives me minus 8 divided by 4. So the gradient of my radius is minus 2. Now, as I said, gradients of perpendicular lines multiply together to give us minus 1. So because a radius and a tangent are perpendicular, we can then say that the gradient of my radius, say minus 2, times the gradient of my tangent is equal to minus 1. So to get the gradient of the tangent, we divide by minus 2. So the gradient of the tangent is minus 1 divided by minus 2, which is positive 1/2. Okay, so we now know the gradient of the tangent is 1/2. We now need the general equation of a straight line, y is equal to mx plus c. So we're going to substitute in our gradient for the tangent. So the tangent is up to here, y is equal to 1/2 x plus c. Now the final thing we need to do is find the value of c. So to do that, we substitute the coordinates of the point that we know lies on the tangent. So this is telling us x is equal to 4 and y is equal to -8. So we substitute those values, so we're going to sub x equals 4 and y is -8. So we get -8 is equal to 1/2 of 4, which is 2, plus c. So we then take away the 2 and we get -10 is equal to c. So the equation of the tangent is y equals 1/2 x minus 10. Cool. So as I said, that playlist is down below with all the separate skills that we need. That's the paper done, guys. Really hope you found this helpful. Don't forget to give us a thumbs up, get subscribed, give us a shout down below if you have any particular requests. Good luck in your exams. Take it easy. Take care.